system. So I'm very pleased to welcome Jeremie to Docker.
Hi, so today I'm going to describe you Jbuilder, which is, as I said, a build system we developed at GenStreet. So initially, we'll talk a bit about how we do open source at GenStreet, how we work, how we go from an industrial setting to an open source setting, just to understand a bit the origins of Jbuilder, because we are not that passionate about build systems that we keep writing new ones. We developed with them. On Jbuilder, it was initially for a very specific need. And after, we look a bit more about Jbuilder itself, what to make specific, a bit its design on its future. And you notice I wrote 4 OCaml projects because right now, if you try to use Jbuilder for anything else than OCaml, it will essentially suck. That might change in the future, but for now, it is very specialized to OCaml. So to start with, different approaches to OCaml development. So we'll talk a bit about how we work with OCaml at GenStreet compared to, for example, in the open source world. Just to give you an idea of basically what we, so the people who manage the open source at GenStreet, what we have to do, basically. So inside GenStreet, how does it work? We have a massive monolithic repository which contains all our code. And that's essentially what a lot of big companies do, like as far as I know, Google, Microsoft, Facebook, they all do this. It's essentially to simplify things. We don't have versioning problem. Essentially, a commit gives you a state of the universe, consistent state of the universe. So you don't need to think about version for like your dependencies. We have a continuous release process. So you imagine you submit a pull request on a project on GitHub, it gets accepted, and it's immediately in OCaml. You can use the results immediately. And to support all this, we developed a lot of in-house tooling. So, for example, our build system, code review system, continuous integration system. And essentially, we do all this to get like a smooth development workflow. We have a lot of developers, who sometimes don't know anything about OCaml when they arrive. Some of them will know a bit more about open source and OPAM, but a lot of them don't know much. And we want them to be able to just write OCaml code, be able to release it and everything without having too much to think about how these things work. It's the same idea that you have admin system that will set up your system, your installation. If you want a new software, you ask them to install it. That's a bit the same, but not everybody has to deal with versioning, big system, everything. Just use it. So that's how it works inside GenStreet. Now in the open source world, so as you probably know, it's quite different. We have many small repositories maintained by different people, either individuals or companies. We have a dual setup with stable release and development repositories. So people typically publish their code on GitHub, GitLab, Bitbucket, personal websites. So they publish it like regularly, like working versions. And when they think their code has reached a good state, they release it into the stable world. So for OCaml, that's typically OPAM. And you get this thing where you have like stability guarantees. It's not going to change. And that's what other people use for their development. To support this, well, we end up with complex version constraints. You need to specify what version of your dependency you are using. You need to make sure that everything is coherent. And so as like the OCaml community grows, this becomes more and more complex. Nowadays, we have a lot of tests to make sure everything works. And typically what people use is a vast panoply of tools which either complement each other or overlap each other. But essentially, there is no conventional element, everyone needs something different. So typically, what people who manage open source at GenStreet, so essentially it's me, Thomas, and lay wide a bit as well. What we do essentially is that we set up the system to go from this world to this world. So I'm going to talk a bit more about that now. So open source agent state. So a bit of history. So we started releasing package about 5 years ago. Initially it was one package. It was a sex clip, the original package. And now, like the latest release, it's about 94 packages. So it has grown a lot, it's becoming more and more important, both in terms of volume, volume of code release, and in terms of interest. Both, I would say, inside of Gen Street, people are interested in releasing their code, like they say, very often they ask us, oh, I wrote a new library, can you release it? They're more interested in participating, like going on GitHub, managing pull request issues. And externally, we are getting more users. So for example, like the last release we did, it took quite a lot of time to get it in OCaml because we had a lot of users, wrote a lot of code basically. So it's good because at least we are not doing this for nothing. But so it's more effort. So now I'll go a bit more into the technical. So how do we do this? Basically, how do we go from this setting with like a massive repository to small individual open packages? How does this work? I will describe the system before Jbuilder to like give you an idea of why we wanted this new tool. So the first step in creating this package in run, so it's to break down our massive repository, which we call Jenga, into smaller repositories for individual libraries or tools. So typically, XPlib, core, async. And essentially, this step is just like splitting the files, so we have a small tool that does this. And the second step, a bit harder, is setting up the individual repository. So what that means is typically making sure we have a license file, setting up open description for packages, so that we can release them later or that people can pin them. And in between, all this stuff is setting up the build system. Because internally, we use a different build system, Jenga, and externally, we use the public tools that are available. So we have to set this up. And so here, there are quite a lot of overlap with you because, for example, Oasis was supposed to deal with this stuff, installation, meta files, and we started with just Oasis files, basically. But as things evolved, meta file became more complicated, and Oasis wasn't able to deal with it. Installation became more complicated, and Oasis wasn't able to deal with it. So we ended up having to generate more and more files, and things became more and more complicated. So it is an extremely complex process. So it requires a lot of adjustments. Basically, in the last version of this process, where we are generating all these files, we ended up with having templates for everything. And for every project, we had to adjust things because it kept on breaking, it wasn't working the same way. A very big problem was that the code that was building internally, for our libraries, didn't build externally. And the reason is mostly because we are starting to adopt new building strategies, like for the module aliases, or just because OCaml build was using OCaml dep in a different way, and there was like slight things that didn't go well. And we, like very often, we spend days, trying to understand why things were failing outside and not inside, and how to fix them. And the fix was to add like manual adjustment, or to go back in our code and add ugly hacks just to please some tools, which was very painful. Errors was really hard to debug, and mainly it's because we just have too many layers of tools. You have like OCaml file, that is your library manager, OCaml that is your build system, Oasis that is like a description for all this, and you stack this thing. And so sometimes it's nice to have like small tools that do individual things. But in this case, we ended up with errors that we couldn't understand. For example, we had a build command, and it was obviously wrong. And we're thinking, so why does the system end up with this? And trying to understand, going up all the layers to understand was really extremely painful. Even sometimes we reported errors on the OCaml build, and the maintainers of OCaml build didn't understand either why this was happening. And yeah, so this tooling, so me, what it makes me think of, like it's something you do very often, like when you're a developer, if there's something you don't understand, a system you don't understand, you kind of write a layer around it, with something to make it kind of do what you want. One good example I have of this, that's what all this ecosystem makes me think of, once I was talking to an admin system that was explaining how they ended up using Python. And he was saying that initially they were using bash scripts for everything. They had a database in plain text file. They were using grep and sed. And it was working. And then there was this new guy who arrived, and he started writing a Python script. And nobody knew what was Python. They didn't understand this small thing. So in order to integrate it in their system, they wrote a layer of bash around this Python script to make it work. It sounded silly, because bash is much more low-tech than Python. But that's what we ended up, with all this tool. A lot of tools that don't understand each other, that just swap each other in one way that doesn't really work. And in the end, you have a system that is impossible to understand. So to go back a bit and just say it, understand how it works, like how we deal with new libraries, executable. So I'm going to describe this a bit more, to explain you how it works, like to go from Gen 3 to open source. So I split this into like Jenga and Gen 3 rules because they're contrary to Jbuilders. Jenga is a very generic build system, and then we have rules that implement our scheme, our compilation scheme, and essentially that implement these Jbuilder files. It's not something that's specific to Jenga, it's something that's specific to our rules. So Jenga, what is it? It is a full feature build system. It's scaled to huge repositories. Basically, because we have these huge, massive repositories, we needed build system that can deal with this in an efficient way. It supports pooling build, and it's supported in the core system. It's not something that's on top of Jenga, it's really in the core of Jenga. And that's quite important because when you have a massive repository and you change a file, you want to get feedback as soon as possible. You don't want to wait 2 seconds to get an answer, you want it like this. You edit your file and you get the error straight away. Otherwise, it gets really painful, when you work with this massive repository. And there are a lot of nice features, like nice user feature. For example, in our setup, once Jenga is running, you get error popping up in your editor. As you fix your code, error go away, come back. You have the same thing for test. Basically, you get the result of test in real time, which is very nice.
Jeremie?
Yeah.
What is huge?
Huge, it's several millions of lines of code.
Files.
Files, I think it's hundreds of thousands. Well, it was that, I think, a year or two ago, but I think we have more now. It grows quite a lot, basically. And basically, we are essentially developing Jenga and making it faster as what the code goes. We are trying to speed up. So sometimes you just need to buy more RAM. Sometimes you need to make Jenga faster. So as we go, we put more effort into it. So Jenga, it was basically a big effort in terms of development. It took several years to develop it, but now it's a huge win. When I started Gen 3 about 4 years ago, we were using OCaml. We had a massive OCaml file that nobody knew how to edit. It felt a bit, like when you look in this bash compilation script when people build big systems with language that are not designed for it. You touch anything and everything falls apart. So it was impossible to develop. Well, Jenga, you can, without knowing much about how everything works, you can go in it, write complex systems, like it's just OCaml development, and do what you want, so which is quite nice.
Marcelo, does Zen still use OCaml for its build?
No, we removed it like 2 months ago.
Oh, okay, so that was another.
It's not, it's an improvement in the sense that we moved everything to Oasis before transitioning to Jbuilder. But this makes everything much more readable and much slower.
Yeah, that's what actually. So when I started Gen 3, I was used to OCaml build and that stuff, and I said, why don't you use OCaml build like everybody else? And essentially, it was for speed. So yeah, back to Jenga on the Gen 3 setup. So how it works in general, we have a few build system admins who maintain the Jenga rules. So basically it's just a few people, and sometimes people will come and develop their own things. The rules we have interpret Jbuilder files, like Jbuilder. And what developers do, like everybody at Gen 3 on a daily basis, is just write these Jbuilder files. So for developers, it's quite easy, basically. They don't have to know much. So a typical example of Jbuilder files you write, you want to write a library foo that use curl async. Well, you just write this, library and foo that use curl async, and you let the system deal with it. So how does that help us for the public release? Obviously, we don't want Jenga because.
Are you going to show us what the rules are?
The rules?
Are you going to show us what the rules are?
Well, I guess I'll show you a bit more in the demo. So for the public release, we don't want Jenga because it's a massive piece of software. It has tons of dependency. And to build like small libraries, we don't want to pull like 20 libraries that don't work on Windows and things like this. But Jbuilder is things that are very like precise description of what you are doing, library executables. We want them. So before we wrote Jbuilder, So essentially Jbuilder, what is it? It is our Jenga rules, but without Jenga. That was the initial version of Jbuilder. And in fact, it wasn't even meant to be like to become a build system that you use on its own. Initially didn't even have incremental compilation because we didn't invent incremental compilation. But then people started using it, and like it became quite obvious that you needed these things. So, and I say almost because what it implements, Jbuilder, is not exactly our Jenga rules, because our Jenga rules, they work in one context, like our massive repository, one version of Linux, like it's very simple. While Jbuilder, it has to work with many different systems. But what is beautiful about this system is that the description we have in these Jbuilder files is quite high level, but still enough to build everything. And because of this, we are able to build the same software in two completely different configurations. So before we wrote Jbuilder, we thought about a few alternatives. So the first idea was to generate makefiles. So basically, one day, like the main author of Jenga, Nick Chapman, he came to see me and he said, what you are doing with the public release, I sorted it out, it's simple. I wrote a thing in Jenga where I can dump a makefile with all the rules to build the code. And for me, I was highly unconvinced by this. And the reason is, how do they work like with this system, Jenga, Jbuilder? In general, you have like some logic written in a high-level language, so typically OCaml, that make decisions based on the environment, a lot of things, that build some simpler compilation rule, basically build like a compilation DAG, and then it feeds this DAG to a simpler system that interprets it and basically run action to compile your code. Essentially, when you generate a file, what you do is that you execute this logic, produce the DAG, and save it on disk. But what that means, obviously, is that if in your logic you are saying if it's Linux do that, if it's Windows do that, it's lost. It's lost in your makefile. So to some extent, you can try to get it back, like try to make your makefile dynamic, but it's really hard. But initially, a lot of people were excited about this, except me. I never like this idea. Well, because since I've been working on public release for a while, I was a bit more aware of all the problems, and that didn't seem feasible. So we did try to implement it, and I did try to think of all the steps. And when we developed some nice tools, like for example, like there is checks that we published recently, like which is essentially like usual programming in OCaml. But well, we never solved this problem, and this eventually went away. Another thing we thought about was like to try to bootstrap Jenga, which is a completely crazy idea. Like Jenga is huge, it's not very portable. That's how desperate we were basically to get rid of the whole system. But now, so back to Jbuilder. So now I hope like you understand a bit better, like why we really wanted Jbuilder, why to spend some effort writing something new. I'm going to talk about what makes Jbuilder specific. Like so it does everything like you would expect. But there are a few more things. Essentially, since I was taking the time to write a new build system, I put everything I wanted in a build system. So we'll talk a bit about these things. So the first thing, which is essentially imported from our Jenga rule, is automatic discovery. So what does that mean? In general, when you use, like for example, Oasis or a lot of build system, you tell the system where your things are. You have a top-level description, basically, and you say, well, my library, true, it is in src. Which is a bit weird when you think about it, because if you use an external library, for example, OCaml or core, you will just say, I want to use core or OCaml. You don't tell it to write it on some other system will find it. It's a bit weird that when you develop locally, you have to take the build system by the hand and point it to where things are. So what Jbuilder does, basically, is that when it starts by crawling your source tree, finding libraries, and while building a database to know where things are. And this is like a simple thing, but it essentially make like multi-project development, so you might know, but Jbuilder, you can put many projects in a single repositories, in a single directory, and you'll be able to build everything at once. And all this, to support this, there is nothing to do, but if you have this, it's already done. Because Jbuilder will just know where your things are. And well, even for like local development, it's quite convenient if you want to refactor your project, you have less things to modify. And now another thing that is more specific to Jbuilder, so it's build context. So basically, in a single run of Jbuilder, you can build against several configurations. Typically, Jbuilder will use like OCaml because that's what people use, So what that means that, for example, you can build the same library, same executable at once against several versions of OCaml. Jbuilder will maintain several like trees of artifacts, each built against a different configuration. Initially, I did this because I was maintaining GitHub for several versions of OCaml, and without this, the workflow is typically you modify your code, you push to GitHub, you wait for the CI to complain. It's very slow, it's very painful. While with this, I just had Jbuilder build for 402, 403, 404, and I get the errors immediately. It's much faster. And one thing that's interesting to note is that this thing that's specific to the rules implemented in Jbuilder. So Jbuilder, how it's structured, you have basically a core that is a full-blown build system that is not exposed to the user, at least not at the moment. And then you have the rules that implement, like the reading of Jbuild and all that stuff, which is essentially like the API of Jbuilder. That's what you get. That's what is documented on what you're supposed to use. And this build context thing, it is specific to the rules. And why is that interesting is that, well, essentially, what that means is that you can have your dependencies, they can cross build context. And essentially, what that gives you is, well, I claim cross-compilation for free. So when you do cross-compilation, what do you have to do? First, you have to set up a toolchain that can build the executable for your target. And that's something we know how to do. Like if you look for OCaml cross-compilation, there are lots of cross-compilation that exist. But then when you want to build a real project, you have a big problem, is that build system never help you to know what needs to be built for the host or what needs to be built for the target. And it's a big problem because very often when you write a project, you will write an executable that generates more code than that you will build as part of your library or executable. Especially in OCaml, we do that all the time. For example, with preprocessor, we generate these executables that need to run on the host. And so, well, it's really painful for cross-compilation. So one thing people will try to do sometimes is to split the world. Say, for example, well, my PPX, they will be built for the host, and the rest for the target. But of course, this doesn't really work if you want to use the same library in your PPX and your executable. For example, you might say, I want to write a PPX that will use OCaml. Makes sense. But because you build OCaml for the target, well, you're stuck. So what some people will even try to do is just run, build everything for the target and then emulate, run things in Wine or another emulator. But in Jbuilder, because you have different build contexts, so it's easy. You just have two parallel worlds. And if you say, well, I want to run an executable on the host, you just get it in the other one. So at the moment, in Jbuilder, you have all the hooks, like from user point of view, necessary to tell it when you want to run something on the host, on the targets, but the actual compilation is not implemented. So there is a bit of refactoring to do to do it properly, but it shouldn't be too hard. And of course, while Jbuilder support everything you would want for a modern build system, with all the tooling we have. It handles your installation by using a generating install file that OCaml understands. It supports several package installation repository. It generates all your boilerplates, meta file, Merlin file, all that stuff. It supports parallel builds, and it supports them. It's not just an extra feature. Basically, by default, builds are parallel because if your build doesn't work when you parallelize, it's a bug basically in Jbuilder. So we have to make things to make it work with parallel build. It's portable, so I tried it Linux OS X on even Windows. Windows with the native tooling, MSVC or MirageOS. And essentially, you don't even need like Unix environment, Bash or Cygwin. You just use the command prompt and it works. And so one thing I try to do is to always report error message, that the user can use. You can do something with it. It will never like dump you a huge thing and tell you well, there is a cycle somewhere in this, or it will always try to explain what's happening. Okay, so what it doesn't do, for example, compared to Jenga, it doesn't support polling builds. It doesn't support fancy communication with Emacs. And I don't think it will ever like support this thing, Like my plan, is basically to get Jenga to be able to understand Jbuilder projects, basically write a Jenga plugin that can understand, that can load basically Jbuilder roles. Essentially, because we already put all this effort to Jenga, to be easy to do it all over again in Jbuilder.
Yeah. I have a wrapper that just reruns Jbuilder build on 9.5, so that works fine. Is there something special that pulling builds needs apart from a wrapper?
Well, essentially, so I said Jbuilder can build several projects at once, and that's fine. Now, if you try, for example, you can fetch the 100 Genstraight repository and do that, and that's fine, it's quite fast. Now, once you have done that, you run Jbuilder again, and there is nothing to do because everything is built, and it will take about 2 seconds. You're going to go, there is nothing to do. And essentially, it's because it's going to traverse everything with all this rule and then figure out there is nothing to do. And obviously, we could optimize Jbuilder, but calling English basically gives you that for free. You load the whole thing at once, and then it's very fast to update. So for me, like the main thing that calling build gives you.
Like for our tree at work, the now build is like 2 minutes. Oh, okay, we'll scan it.
Yeah. So like for our tree at work, the null build is like a second. Is that all just a bug in Jenga or Jbuilder that the null build takes so long?
We've got like 200,000 targets. I don't know exactly what it is, but it's quite a lot.
I mean, I imagine you have some caching probably, some stuff.
That's even on Windows, so I imagine we have a lot less.
No, I mean, what build system do you use? I mean, I don't know, I don't know how it works, but I imagine to do this build very fast, you must cache some.
Okay. You can't open 200,000 files in a second, right?
Yeah, you can.
You can?
Well, you can't open them, but you can stack them.
Also, you hold on the files open.
No, but
No. You can open it enough to get the timestamp rather than get the contents.
No, but it's not the stats that takes time. It's not the stats that takes the time. Basically, like the first step, like when you start Jbuilder, it will scan your tree, read this Jbuild, build like the actual rules, interpret these things, and this is what takes time. And, maybe it's not implemented in the best way possible. That's probably why it's slow. Basically, it does too much stuff. But you could optimize Jbuilder to be really fast. It would be maybe a lot of work. I'm claiming since we did this work in Jenga, we're not going to do it again in Jbuilder.
Yeah.
Maybe some.
So I would say I would just optimize it for fast builds, and then I notify around the outside.
Yeah, possibly that's one approach. At the same time, if you are I don't know, if you are on a laptop, it will still take some time to interpret all this stuff. If you
I think maybe we're just doing far more. I mean, I was talking about time to Jenga, but we may just be doing more stuff generally. Can't set up the rules, but
We try to hash the files, see if they've changed.
yeah, it does. It usually does.
well, Jenga does this,
It
not
doesn't
Jbuilder.
change.
Jbuilder just use timestamps.
Sorry?
Jbuilder just use timestamps, but Jenga does hash the file.
So Shape does timestamps to see if it hasn't changed in
Yeah, I
file
think it's
sizes,
just-
and then hashes
I think
only
it's-
if it notices the timestamps
Yeah.
changed.
All right. So now I'm just going to talk to you about some design decision for Jbuilder, basically. And well, for now, it's something that you don't have access to, but one day, Jbuilder will support plugins, and that's an API people will be able to use to write more interesting stuff. So in the initial version of Jbuilder, one thing I did is to keep the role, the actual build role, very simple. Essentially, a static set of targets. So compare, for example, to Makefile or OCaml build, we essentially don't have rules with percent in them. In general, when people write rules like this, they will write very generic rules, and then it's a bit complicated because you have to think about how to select a rule for a given target, how the precedence work, and then these very generic rules have to determine how they pass arguments, to the underlying command. So you have various complex systems to support this. In Jbuilder, it's extremely simple. You have one target, a single role, basically. And essentially, I didn't need to write anything more complex. Because if you are using OCaml, you just say, well, I iterate over on my modules. When I generate one role per module, it's very simple. And that makes the initial development of Jbuilder very simple. So one day, it will probably be a bit more complicated because sometimes you want to generate more target dynamically. For example, if you have plugins, you might want to build the plugin, load it, and then generate more targets, things like this. But for now, it's very simple. Or at least, the system is quite easy to understand. And one thing I used, to represent my build rules, so it's an arrow, which is one way to represent computations. In Jenga, we use a monad. And the reason I use something more, a bit more static, basically, is that I want Pale to be able to scan my rules and find out most of the DAG without doing anything. And the reason for that is that, so if you remember initially when I said we generate OCaml files, given a source tree, I want to find out what it needs, what external it needs without doing anything. And this is very simple because I have most of the graph. So essentially what you don't have in this is dynamic dependencies. You need to run it to get them. But dynamic dependencies is mostly OCaml dep or thing like this. Without it, you get most of what you want. And basically, so that's enough for us to generate OCaml file just by looking at the rules. And it's a nice way to reuse the code. Basically, this build arrow, it will allow to compute, so just by inspecting this type, find out what are the targets, what are the list of dependencies, what are the list of dependencies that you need to interpret the rule itself. For example, if you want to interpret the result of OCaml dep, the rule itself will need to read the result. Will be action that you generate, like running OCaml seed. And it composes quite nicely with this arrow. So now I'm going to just show you an example of what the API looks like. That's typically a rule to build a module. So we'll call OCaml C on this module. So to describe command, we have this thing that's a bit like what we have in OCaml build, a small DSL one command. Except you don't have any bash, basically. In Jbuilder, I try to exclude everything the shell from everywhere, just use the basic things so that it's portable. So we have this here, with small DSL where you can specify both dependency target directly in the command line. So here I'm saying I give the wrong way around, I think. Anyway, so I give argument, and I just say this argument is dependency, this argument is the target. It's quite nice to write. And when I want to compose my things, so for example, that graph, it's a computation that we read due to OCaml dep. build a map, from module names to what are the dependencies. When I run this rule, I just say, okay, well, here, so if you don't know arrows, basically, like, the way to think about it is that you have a computation, and you have this like value that streams through the code, basically. So here, like, I have this dependency graph that streams through here. I'm looking up my module in this, and I feed it to like dynamic path, which let me declare dynamic dependencies. Basically, when this will be evaluated, this will yield a list of paths, and Jbuilder will know to wait for them in the action, basically when it runs the actions. Is that clear, this? Is there any question about this? So one thing that's actually nice about using an arrow, because like you have various ways to represent computation, that you naturally, what I found that you naturally build your graph in a more like compact way, because you think a lot about how the information flows through your graph. And if you have done an expensive computation and you want to use it twice, you just split it rather than just put your computation twice, like at two different places, which would mean you have to compute it twice.
What can you not do with the arrow versus a monad? Like, can you discover dependencies dynamically?
Well, yeah, but you can, so this discover the dependencies dynamically. What you can do, well, is essentially, for example, if you want to say, if you want to do an if, for example, you want to do if file exists, well, that needs to be a primitive of this. Right. With an arrow, you just like, you evaluate something, you get your, like the monad, so you get your result, and then you can build a new monad.
So there's no data-dependent control flow in the graph?
Yeah. Yeah. Your graph is static. But it's enough to help you. Yes, and now, so that was the rule. How did the Jbuilder and the parallel build? So that's quite simple. Basically, I implemented a mini like LWT async monad. So I've worked a lot in the past on LWT and async, so for me it was pretty clear that I wanted to use that. And that made supporting parallel builds like extremely simple. Essentially, I get my list of dependency, I just iterate through it, start the build for everything. And because it's like cooperative threading, I don't need to think about how many threads I start. So essentially, like, it's a very simplified version, like the implementation of this in Jbuilder is like 100 lines of code. And the reason it's very simple is that because the scheduler only knows how to multiply processes. And that's something that's really easy to do on both Unix and Windows. Easy to do in a portable way. Contrary to, for example, multiplexing like I/O, like reading pipes or sockets. It's extremely hard to do this in a portable way. It's hard to do on just Unix, and it's even harder on just Windows. While processes is, for some reason, it's extremely simple. All right, so I just like to talk a bit about like, the future of the builder. So what will come? So first of all, we'll have the release 1.0.0. So technically, Jbuilder could be in 1.0.0 because it's used in production already. I've been postponing because I wanted to sort out. So first, two things. I wanted to have a full story, for like having like setting up your project, publishing it, generating documentation, and everything. So far, we have pretty much everything except generating like API documentation, HTML pages, and publishing them, but that will come soon. And as well, sorting out the versioning story. Typically, like the Jbuild file, the description is version. You can write in your Jbuilder, Jbuild file, Jbuild version 1, so currently there is only one version. And in the future, if there is a breaking change, you will say Jbuilder version 2. And by reading this version, Jbuilder will know what parser essentially to use for Jbuild files. But still in one version, you will still get backward compatible changes, additions. And I wanted to find a way to work with this nicely, I didn't want to have like minor version for the Jbuild files because then you end up having versions of Jbuilder, versions of Jbuild files. That's very complicated. And then what Jbuilder will do, since it's already interpreted one file, it will just check that you put the right constraint in your file in Jbuilder. And then if you use a construction that is not supported by the version you put in your file, it will compare. So that should be quite nice for users, basically. When they start using new features in the project, Jbuilder will them. You need to avoid your constraints, and that's it. Another thing, so as I said before, is the bridge with Jenga. So there is quite a bit of refactoring to do in Jbuilder to make this possible, but shouldn't be well. So that's something that will come like maybe long term basically. And OCaml plugins. So currently Jbuilder is very inflexible. If you want to use it for anything that's not in nature, it's impossible. For example, recently we added OCaml support. If it wasn't done in Jbuilder, it's impossible to do outside. And of course, that's not very viable for the long term. You can't keep pushing things in Jbuilder, making it more big. So Jbuilder will have plugins. The way it will work, because I want this to be quite smooth, you know, like you don't have to call Jbuilder and tell it what plugins you're using. Essentially, in your Jbuilder file, you will use a syntax for stanza that will make it clear it's a plugin. So, for example, X:, for extension. And then, let's say you want a plugin for C-types, you set up rules for building C-types binding. The name that you put here will tell Jbuilder where to find the plugin. So typically, for example, you look for a library called C-types.jbuilder. And then you'll be able to put C-type.something if you have several things. And essentially, what Jbuilder will do is will load this library, and this library will tell it how to interpret this or to generate rules for this thing. And one thing I want to do as well is currently in Jbuilder, everything works whether it's installed or not. You know, that's what allows you to just pull your dependency in your workspace and build everything. And plugin will be the same. So typically, you will be able to have a plugin in your source stream. Jbuilder will build it and then load it.
How are you going to version?
For versioning for this, that will be the rule of the plugin, I guess. You know, maybe there is GitHub will be one or something.
So we'll say Haskell went down this route of keeping the plugins outside the build system like this, and it was a disaster, and it was completely possible. And we eventually moved them all back into the build system, and we're much happier.
So back, you mean?
I mean, it seems like for core things, they should be inside. Like for things that are going to be widespread,
if
they're inside, you then don't have any version which presumably starts happening.
Well, so it wasn't that. But it just got to the stage where there were a few that worked, and the plugin mechanism was inflexible enough to support what people wanted to do outside, and it all just got horribly messy. So yeah, just put them all inside, problem solved. And there aren't that many plugins people wanted to actually use.
Yeah, that's like when you do the poll of this and people go, of course, when they community plugins, it's like 5 in OCaml build in a whole of OCaml for the last 4 years. So I don't think it's real. They are. But fundamentally, though, like if there's a quick release process, I think it's worth the experiment. Versus, distributed build, you lose a lot of the benefits of latency.
Well, and you know, any semantics about analysis is much harder to do with distributed plugin.
But also, I mean, one thing, that's one possibility, but we'll have to think about. You know, I don't want to have to support everything, basically. Like, you have to make all this work, basically.
But part of that is perhaps a kind of a CI question, because if there's an automated way to test all the rules working as part of the submission process, and then OCaml itself can be used as the mechanism to make sure that new versions are able to work. Because you'd end up like OCaml find just rebuilding the whole universe, which takes 6 hours. It doesn't seem too bad.
Yeah. Well, actually, like you could do even something quicker, like Jbuilder, the latest version, you have like a command to dump internal rules. Basically, it builds a DAG and then it dumps the rules. And so this, you know, as I said before, like you can use this to generate makefile, but it's not very useful. But one thing is good for is detect when something changes. You know? For example, you write a complex feature and you think, what did I change? You know, at the low level. It's a bit like when you write performance sensitive code and you open the assembly. You can just generate your makefile based on tip. You diff it and you see exactly what it means, you know, for the actual command you run. And for example, that could be useful. Like you just generate the rule for the whole world. It will take some time because you still need to build a few things like the PX thing like this, but it's much faster than actually building everything. Yeah. So, right. So yeah, one last thing I wanted to say about plugins. So if we use them is well before basically any of this will be available is that you will need a proper stable API inside Jbuilder. I don't really want to do it like compiler lib style where you tell people you can use it and then it's a mess, it keeps working. And that's it for this one question. Is there any question about it?
What about Windows support?
Well, it works. I mean,
it just works.
Well, if you go on the web page, you know, like you have a Jbuilder badge. Well, it works.
So yeah, I guess that's using Sigma at the moment, right?
No. It's basically, so you know, that's one thing that's like another reason I find the idea of generating Makefile a bit annoying is that just the OCaml distribution, it gives you everything you need, you know, already to build a system. It gives you Unix.create process, which is a portable way of running processes. And that's what I use basically in the builder.
Right.
And that's enough to make it
so I guess I noticed some of the rules use SH invocations.
Sorry?
So some of the rules inside in the community packages, like C types, for example, they generate executables and then they use shell redirections. So I guess those would require Sigma to run.
Basically, the Jbuilder support like redirection, like dumping your to a file, thing like this. And like you don't need the Sigma for that, you know, like you just open the file and pass the file descriptor to
it sounds more like some users of Jbuilder are using the non-portable way.
Yeah. Basically, like Jbuilder provides you a small DSL, you know, in your user role to do this kind of thing. So it doesn't support many things, but it supports enough for the common thing. And yeah.
Have you built all the packages using Jbuilder?
No. I have built basically I build based on Windows.
Yeah.
Well, actually, so making the packaging themselves, you know, fully portable, it's a bit of work because sometimes it's really convenient to just shell out, you know, cell or whatever. It is a bit of work, so we did it for base, and then it works totally fine.
I guess things like I was using the configuration DSL, so there's a staged DSL for testing configured features and so on, and that's quite nice because it seems it's much easier to make portable. Because then if you could have some kind of a pipeline mechanism for running an executable, sending the output to a different file. So it's very small scale uses of shell redirections right now.
Well, I'm sure that in the demo, basically, like we even do pipes, in fact. Like as long as you don't implement them with proper pipes, it's easy. You can just jump to a file and then feed the file to text command.
Is the build context thing completely tied to OCaml switches?
Right now, yeah. Basically, so the way you configure them is by giving an OCaml, potentially an OCaml route and an OCaml switch. You could just use them by giving a configuration file with everything Jbuilder needs, you know, typically where to find OCaml out, where to find libraries, things like this.
And that's possible now? Or
that's not possible, but well, you know, so far I've developed things like as I needed them. Like if someone wanted to add this, you have no problem with that.
Personal interest developing OCaml.
So what would you use that for example?
Developing OCaml itself.
Because
it would allow you to compile the 4 ports simultaneously. Waiting for CI again. But I have a setup where you can get 4 compilers ready, but that's not an OCaml.
But like technically,
set itself.
Okay.
Let's talk.
I have a patch I started yesterday to redirect it through a Docker container. So then I can build all the Unix distributions as well as the multiple version. So that would be a side.
Yeah, because I would say doing it for me is a temporary use case.
And I think we do have Windows native containers now as well. So it could be an option for really quickly trying to add packages blazing containers. I think they're quite early days at the moment.
Yeah, it's quite annoying. Right now we're using OCaml switches. When you run OCaml, it takes a global lock. So if you have an OCaml installed in a shell on one Jbuilder that is configured with OCaml switch, it will block at the beginning, waiting for the lock.
Also, with containers, it can be completely independent. But you'd have to figure out how to depend on, if rules depend on context, it's a little bit trickier. They'd be in two different containers. But,
so they would have to run in different containers. So what's this tricky about them?
It's just you have to map the host file system into the container, which we do support. So it's just that you have to set up the rules quite carefully so that you have what appears to be a global file system, but in fact it's been mapped into containers.
But currently, like the only place where it crosses, like currently there is no cross, just for cross compilation. Right.
because Docker for Mac supports ARM as well, so it transparently redirects into QEMU. So we could also do Raspberry Pi compilation if we support the same scheme. So it'd be quite nice to build ARM and Windows and Linux from one Jbuilder invocation. Which I believe was one of the frequently asked things for. So I guess the two approaches there. One is reconstruct a CI environment on your laptop, or just eliminate the need for CI. As a local development thing, which seems to be a preferable solution. I don't know who asked for that. I think it was David who was asking. Never mind.
All right. Should we move on to the demo now then? Or we'll take a break or something?
Are there any other questions?
Sure. Is there a more short-term solution? You said about plugins and there's a bit of debate about what to do. There's often some really simple thing that you want to do, like don't use -03 on old versions of OCaml. It's just some simple thing like just insert an environment variable into here, or just something we can use in the short term.
Well, for like this question, because you put it on GitHub, I answer like, well, you have used my answer basically, or?
I know you can switch the OCaml format file. Horrible. Pull request it does that because it's disgusting.
So basically, like the OCaml format, essentially, it's like the same idea like when you have a software like Git, and then you have shell script as hooks, It's essentially you can't support everything at once, so you just give the user the escape hatch, and like the OCaml syntax, this is what it is right now. I don't want to encourage people to use it, but like if you want to do something that Jbuilder doesn't know yet how to do, it's your temporary workaround basically.
But also for these behaviors, why not just integrate them into Jbuilder? So I presume we should never use all three on a buggy runtime. So we should just by default have it just do the right thing. So
possibly.
I guess I'm trying to distinguish how many of the there's been a lot of kind of armchair conversations, but I was just wondering how many of the as we start using it, how many of the features are really unique to our use case, and how many are just everyone should do it by default. The majority are probably.
One of the things is that with the OCaml build, you need to write plugin for everything, because the OCaml build is expected to understand the entire world, it's expected to know about all of the OCaml options. So when new option is added, then you need to modify the build system in order to understand it. Whereas Jbuilder surprised to be slightly more willing to pass uninterpreted stuff to, like you can just say there's a flag and you put it as a string. There's lots of situations which in the OCaml build where you needed a plugin, but Jbuilder don't, because you can it doesn't expect to understand every option. Or you just
well, essentially what we have in net for OCaml build is just a tag flag that takes the tags you want to pass. I guess. I guess like Jbuilder basically just tells you pass the flag because it's simpler. I mean, that's what like if you know the flags yourself, you don't need to wrap everything. Like there are some flags that are wrapped, basically Jbuilder will handle itself, but the rest.
Time for a quick demo for the food rounds. I think food is about half an hour away.
Yeah. All right, so I've prepared a simple demo. So basically, I just like a walkthrough to a few things you can do with Jbuilder. So I'm going to set up a small project, which is not very interesting. It's just going to be like some mass function, so factorial function. And then we're going to package it, test it, and see what we can do. All right, so how does it work? No, actually, sorry. Okay.
Screen share. Share your terminal.
Yeah.
Perfect. You just increase the size of your font size a bit
more. Yeah. So,
if you go try to go full screen with the terminal, and then increase.
No, but I need a. I can't go full screen. I need some other stuff. Well, I guess I can just increase a bit.
Just Apple plus increase the font size. So I'm not sure how to fix the contrast of the screen.
Or maybe I can change the color, like if they are not really they are hard to read.
Yeah, it's probably.
Like maybe white background, that should be easier.
This is a smart TV. I have no idea doing it. Turn up the brightness. Yeah.
It's not.
Seriously, how does it increase brightness? Is brightness even a concept in 4K TV? Is 100%?
Yeah.
Okay. Some turn off the sun.
So how do I change the thing?
Turn the blinds down. Yeah.
Turn the lights down. We have to make sure the lights down.
Oh,
Yeah.
the lights are
And
motion
we-
sensors. You can't
yeah.
turn them off. Smart building.
That's another thing. But just buildings this.
Okay.
You did not read this?
Yeah, let's
Is
start.
better? All right. So let's try like this.
You haven't seen?
Okay. So let's start a small project. So like the project will be basically a math util libraries with a factorial function. So I'm going to start by writing my factorial. Yeah. All right. Oh, well. Why is it going back to? Well, maybe if I do this. Okay. All right. So nothing really fancy. Okay. So now I've written my library. I'm going to set up so the build. I'm just going to tell Jbuilder about my library. So it's going to be called mathutils.
Can I just ask, do you have to produce the MLI file?
Sorry?
Do you have to produce the MLI file? That was my next question.
Oh, you don't have to, but it's good practice. I mean, I'm not going to show something that's bad.
You made it mandatory.
So far, what do I have to tell Jbuilder? Well, I just have to tell Jbuilder that I have a library called mathutils. I'm not telling it that there is a module fact because I just have one directory, one library. Jbuilder will just use everything in that directory. But in general, that's what you do. You have one library with many files on the library. So let's start by trying to compile this thing. Okay. Okay, so I'm going to call Jbuilder build, which is like the main command used for building files. And I'm going to say src. So what I put in my Jbuild file here, like the name, it is the name of the library as you will use it inside the code. You know, basically all modules of the library, such as fact, they will be available as mathutils.fact. And the way this will be implemented, it's left out to Jbuilder. In practice, it will use module aliases. So basically, you will here the name you have to put is a valid module name. Basically. So I'm going to ask Jbuilder to build like my archive for my library. So typically CMA, which is what OCaml uses for libraries in Bitcode. So I asked Jbuilder to build this. He did it. So if I look like in SRC, there is nothing because like by OCaml build, Jbuilder puts all these artifacts inside the.
Jeremy,
yeah.
it's missing the bottom line.
Oh, damn. Maybe if I reduce the window.
Yeah.
Better. Okay. Can we switch off like this?
Yeah, how do you what is that? Just click on that thing, but don't.
No, but I don't have it.
Oh, I have it. Try my phone. How's that?
Yeah, it's better. Still too big, this thing. So, doesn't fit in the screen, that's the name.
Yeah, that's
fine. Okay. So yeah, like OCaml, typically Jbuilder puts his artifact into an underscore build directory. And what we have in this build directory is default, which is basically our build context. By default, Jbuilder will build a configuration that reflects the environment in which you run it. So typically it will look up OCaml in the path, something like this. And to find out libraries, it will use OCaml find. So it will put everything in default. And we also have this log file. So before showing you more, I will show you a bit the log file, because it has a lot of interesting information. So at the beginning, like you can see this thing, it is basically your build context, like all the information the builder has about the build context. The builder doesn't solve this stuff essentially, so that if there is a bug, like a crash, people just put this up on GitHub on that list. We have a lot of information about the context. We don't have to ask individual questions. And then it prints you all the commands. So one thing is that Jbuilder always tries to print you commands that you can just run yourself. So typically, if you like copy paste this thing, like a command here, and run it, it will just work basically. And it prints command, and it will print as well the output of commands. So for example, if I go back in my factorial and I put a type error, I will get it in my log. It will print, it will give me like error code, all the outputs. And this would work if like there were several commands in parallel that produce error, you will get everything. All right. Our library example. So typically, like the artifact you can see will be in here. So as you would expect, you have your archive or your CMI. You have this weird thing. It's basically how Jbuilder implemented your namespacing, basically. So currently, we don't have proper namespacing in OCaml, so Jbuilder does some hacks, basically. It works nicely for now.
Do those hacks ever leak into your backtraces and sort of other debugging?
Well, yeah, they do. I mean, because
that's what you need to show.
Yeah, I mean that's one like drawback of not using proper namespaces is that you have basics everywhere.
Right. Doesn't that stop when we merge 10-10?
Yeah, that will. So yeah, there are some.
Yeah, so that's short term.
Some heuristic to improve this. Yeah. But I mean, for the long term, we will need like proper namespaces. And then so you have all these files which basically Jbuilder generates, are internal to Jbuilder. You're not supposed to look at. All right. And if we look at the source tree, we can see that Jbuilder as well automatically generates .mirroring for us. Basically, so mirroring it is what people use these days like, to get nice feedback in the editor and everything. Like it's a nice development tool. So Jbuilder, because of this thing technically they contain nothing interesting, there is no reason for the user to write it because all the information is already there. Jbuilder generates them for you. Well, yeah, I mean technically Merlin could just could just read your build log basically.
No, but actually, I think to different that he should look to the CMT files because you actually have the concrete compile commands that was used to produce the file. And he could just look at that and know these files.
No, indeed. Well, anyways, in the meantime, Jbuilder will do that for you. All right, so now, so we have written our library, we can build it. Let's try to write some tests for it. So we'll show you typically how to do that with Jbuilder. So I'm going to create a test directory, and I'm going to write a test. So as I said, the library is available through mathutils. And I'll write my test I'm going to put an error to make it interesting. So this is my test. Now I need to do two things. First of all, I need to tell Jbuilder how to build this thing. Typically this is an executable, and how to run it. So to build it, first of all, I will just say to Jbuilder there is an executable named test. So here I put typically like the name of the module containing the entry point of my executable, and I tell it it's using libraries, math utils. So nothing really fancy about that. For example, well, let's try to build it. So typically when you write an executable, Jbuilder will know to generate this executable with extension exe. So it's using exe typically because at least it's the same between Linux and Windows. On inside your build, it's nice to have an extension for everything. It makes it easier to dispatch things. So let's try test.exe, and that's it. My executable in build info, so I can run it. And now, typically, one thing I want to do is tell Jbuilder that this is a test, so that if I have many tests, I can just tell Jbuilder run all my tests, and it will know to run this. So the way this works in Jbuilder is with aliases. So typically, an alias is an alias for a set of targets. So let's see how we define an alias. So I tell it the name of the alias, blah, and I give it what it depends on. So by just writing this, I told Jbuilder that I have an alias blah that exists, and that it depends on test. And now, so if I remove my build, I can ask Jbuilder to build an alias. So the way you ask Jbuilder to build aliases is by putting a nat, prefixing the name with a nat. So test blah, and that's it. Jbuilder build test.exe. One additional thing we can do is tell Jbuilder that this aliases depend on an action. And typically, if you are writing a make file, it will be the same as saying I have an action that produces a timestamp file, or it depends on its timestamp. So how does that work? We say action run. So you see I do something that's similar to what you wrote in my file. It's typically a variable that Jbuilder will expand to dependency. And now, when I ask Jbuilder to build the alias, it will know to run the action. So it has all the action. And more interestingly, so we have a few default aliases in Jbuilder for common things. So typically there is the alias run test. That's typically what you should use. And one thing interesting about this alias is that it's recursive. So basically asking for run test at the root will run your test in your whole subtree, basically. So that's typically how you run tests with Jbuilder. All right. And well, in fact, for tests, there is even like a shortcut. You can do Jbuilder run test, which is the same as the other command. Okay, so well, let's fix the test. Okay. And so for now, Jbuilder, like if it has run a test and it sees that nothing has changed, it won't run the test again. So that if you have many tests on a few files, you just run the one file. Okay. Okay, so now that we have written a library on a few tests, we are going to set up the installation of this package so that other projects can use it. So how do we do this? Well, first of all, we need to tell Jbuilder that in our project, we are defining a package, which is essentially a set of executable on libraries. And the way to tell that to Jbuilder is to simply create an open file, because you will need to write an open file anyway. Jbuilder will just use this as well. So let's do it. Let's say I create a package mass utils like this. And Jbuilder, just by this, knows that the package mass util exists. You are basically building this package. And you can tell it to install things as part of this package. So the way you tell it to install things as part of this package is just because you might have in your project, you might have libraries that are just internal null, for test or something like this. It's quite simple. You just give a public name to your library as follows. And the public name typically has to start with the package name, so much utils. Like the reason is that that's typically how things are installed, like lib, package name, and then your artifacts. And if you had more than one library, you would put package name dot something. So here again, like we have quite, there is a bit of redundancy between all these names, but because that's how things work at the moment. Maybe in the future you won't have to duplicate your names, but for now you have to.
So to be clear, the math utils, the name is the CMXA archive name, and the public name is the OCaml file name.
Yeah, basically. That's it.
There's no reason why those can't be unified. Like there's.
Yeah, well, except like you can't use dash in here because you can't use dash in module names.
No, but you can use a dash in CMX archive.
Oh yeah, you can, but it's also the top level module of every, or that you can't do that.
Oh, I see. Because a lot of our libraries are not they're not wrapped.
Yeah.
So we just.
Well, yeah, in this case, yeah, you could unify them. I mean, like just at the moment, it's always different. Things unified. So if I unify them in Jbuilder version 1, that is super painful to do anything. But yeah, you have to duplicate.
The name is always the same as the OCaml.
Yeah, well,
Yes,
that is enforced.
Unified that.
Yeah, at least this is enforced.
So yeah, I think this might not be clear actually. So there's two modes you can use: it's the wrapped true and the wrapped false, and they're quite different. So it is worth explaining that briefly to you.
Yeah. So basically, like, so here, if you look in the test, I wrote open math utils, and I think it's available through this. So that's the default mode of Jbuilder. But you can also tell Jbuilder not to do this by writing wrapped false, and essentially, fact will become a top level module. That will be available directly in the top level namespace. So this is in general bad because if you have two projects defining the same module, you can't use them together. So it's better to wrap things. Especially, like, for example, when projects don't wrap their module, this is a huge pain. Well, especially like when you import code, for example, at JScript and import a project, systematically clashes, like things like C tags that define unit or whatever, like it clashes with everything. So it's really painful. So namespacing thing is.
Why do you support that?
Sorry. Well, basically because a lot of things use this at the moment. Basically, a lot of projects in OCaml manually namespace their thing. Like they will, for example, at WT, you have all modules are prefixed with WT. And like migrating everything as once, it's the work. So you break the whole world.
Yes. So I think in that mode, it's for compatibility, so you don't have to redo all
the basically.
I think it's worth making it clear that it's like when namespaces appear properly, there won't be an option to not have that.
Yeah.
So, but it's essential for the transition. To have this.
Yeah.
But in that mode, the name it also just takes all of the modules in the directory, I think, and it just links them to the top level when the wrap is false. So it confused me a little bit because I tried to specify all the names in the name field, but it didn't work. But I didn't need to because it just grabbed.
But you need to specify the names if you have several libraries inside the same directory. So you don't care. Yeah. All right. Okay, so now that I told Jbuilder that my package exists and that this library will be part of this package, I can ask Jbuilder to generate an install file, which is basically what OPAM will use to know what to install on the system. So because there is mathutils.opam, Jbuilder knows how to build mathutils.install. And if you look at this, that's typically, it has listed all the artifacts of the library, plus a few other things that is installed by default. In practice, it will install as well if you have a README thing like this, it will install them in your Docker directory because there are some tools that do this. Okay. And once we have this, we can install things. So typically, So you have Jbuilder installed that will install things using a tool called OCaml. But typically in OPAM, OPAM will do that itself. It will read the install and install it.
Can you turn off the bytecode builds and only build native code?
Yeah, you can do that. So typically, let's see, you will do this or native, for example, or you can do best as well, I think. But yeah, so basically we'll do this. And there is also another thing you can say no DIN link. Well, I don't know the syntax. And it will turn off DIN linking, so you will do a bit less stuff as well. Okay.
It might be used in the rules, I guess. For a lot of our code, we just want to build native code, right? Not for a lot of most of the real world projects. So that shouldn't really be the build rule, should it? That should be in Jbuilder itself to say just build me the native.
Oh yeah. Yeah, possibly, yeah. Yeah. But yeah, currently, so you can say like best basically for the best of both, and especially for executables, if there is no native code available, the exe will be the bit code basically, built in like in a special way so that it doesn't need like shared libraries. All right. Okay, so and in fact, because this basically we use quite often, there is an alias for it. So it's Jbuilder @install, which is an alias for all the install files. Typically, if you have several packages, it will depend on all the install files for the various packages. And because typically this is what you will always run, you can, if you don't specify any targets, this is what it does. Basically, Jbuilder build is building everything that's installable. All right. So now, one interesting feature of Jbuilder, you have like set up the build everything. You want to test, for example, let's say you want to test the module fact in the top level. Typically, what you would do with a build, like another build system is that either you would run your top level and then tell it where to find the artifacts, or you would install everything and then start the top level. But Jbuilder has a feature called Jbuilder exec, which essentially run a command in a virtual environment where it's like if everything was installed on the system. So for example, let's try this, Jbuilder execute up. Without having installed anything, I can do require mass utils on my resist. That's it. And well, I mean, I'm using a normal integer.
It's using your locally built copies and everything.
Yeah. And basically, what it does, so the way it works is, I mean, it's not magic. Like it's just like it sets up a few variables, you know, that are read by the various tool.
Right.
You know, like pointing to the underscore build. So you can see this build installed, and in fact, what it does is that in build, it just creates a tree that will be the same as when installed. So currently, you have only things that are installed that are available. Like for example, internal libraries are not, mainly because there is no global name for it. I think later I will add some things so that you can refer to them and you can test your internal libraries this way. But
pretty much all of the Cambridge undergraduate students doing projects this year, OCaml had this problem. They didn't understand how to interactively build and test their, like the way you can in F#, you know, just with for your local trees.
Yeah.
So they could do it with OCaml for the global stuff. So if there's some way to overlay like an OCaml find style setup inside the underscore build and just add that to your account like that would be amazing.
Well, that's exactly what it does basically. Yeah. Yeah, basically, like if I start, I don't know, like if I start Jbuilder exec bash, I can do, I can ask about it. That's it. I find it inside the build.
So if you use OD in the top level, you can also just specify a module name
What's the local?
Yeah. You just need to specify a module name, not even a package.
Oh, because it uses the CRC to look at that.
Yeah.
So I think for our interns here, it took them 2 weeks to get a working development environment here in Joel or so. I don't think we ever really got a successful development environment. So somehow we need to write down how this stuff works. So he's the biggest blocker.
Using Godig, something.
Doesn't work?
I think it's just loading some stuff.
Oh, maybe the cache.
It's not in the cache.
Oh yeah, I just installed it yesterday, so well.
Interesting.
Okay, well, I will.
No, that makes sense.
There's too many things. This is called Matthews.
But why do they have a different CRC if they're built off the same? One is simply built.
No, it's just in it.
Just because you're using module values.
No, but that's weird that I don't understand why it's looking for it in like the build context. It should only look for it in install. So I don't. It's just normal. Like the one in install is just a sim link for the other one. I don't know. Well, I have to debug this anyway. That's weird. But anyway, so back to this. Now that we have done this, we are gonna write a small binary using this. So like a small binary that will compute the factorial on the command line. Install it, and have a man page for this binary. All right, so bin. So I'm going to copy the one I wrote yesterday. Okay, so what this binary is typically using CMD liner to handle command line arguments and generate a man page. So first thing I'm going to do is tell Jbuilder about this binary. So executable name fact. I want to install this binary. So same as for library, I'm going to give it a public name. And this essentially is how it will name when it's installed in your bin directory. So I'm going to call it like mathutils fact. On this executable, I want to use my library mathutils. So typically here, I could use mathutils or I could use mathutils like this. Both name works. Since inside the workspace, you can use like, the internal name or the public name, it doesn't matter. And CMD liner. And that's it. Okay. And same as before, I can do. That's it. I get my binaries. So now, sorry? Oh, no, sorry, yeah, of course, yeah.
Oh, yeah.
All right. And that doesn't work.
It's
What did I do?
It's factored EXE, not me fact.
No, it should work with.
Oh, yeah, you need
Oh, yeah. Thanks.
Could you scan the command line for dependencies and automatically build them?
I know, All right, so that's it. So now let's capture this man page into a file and install it into the main directory. So what we have to do is write a custom rule, basically, that does this, and then tell Jbuilder to install the result. So first of all, like the rule, so that's how you write with the rule in Jbuilder. So I tell it what are the targets. So typically, in fact, the dependencies. Like the TXT and the action. So that's an example of the action. So I will say with 2.2. So names are quite long, they are descriptive. With stalo2 like the output of my thing, I will do run the program. And I'll say help equal graph, which basically tell CMD liner to output a man page. And I will tell as well Jbuilder that I want to install this thing. So since it's a single file, like not a library and executable, I need to tell it manually to install it. So I will say to tell it to install in the manual section. And I want to install mifact.1. Jbuilder build, and now I can do. That's it. I built my main page, and it will be installed. Okay, so now I will show you two more things basically. So one last thing, I want to split my package. Basically, I want to say that the binary will be in a separate package, mafutilbins, because there's more dependencies, and I want to do it this way. Well, first thing, I need to tell Jbuilder about this package. So same as before, I tell it mafutilbins exist, and now I need to split and tell Jbuilder, well, this library goes in this package, the binary goes in the other package. Well, for the library, it already knows where it goes because of the public name, which is the name of the package. And for the executable, I simply say it is part of package mafutilbin. For install, same thing, I have to tell it what package is part of. And now, when I do Jbuilder build, it will generate a few install files. Each will their own thing, basically. So binary in one, library in the other one. And technically, when you will run this from OPAM, if you install first mafutils and then mafutilbins, because the way OPAM works is that it fetches the source, extracts them with the thing, and then throw it away. So when you build mafutilbins, you won't have any more the artifact for mafutils, but Jbuilder will be clever enough to know to get them in the install part of the world rather than build them locally, because it knows what is part of what. And if you say I want this package only and ignore the rest, it will know to deal with it.
It also seems that half of the information in the OPAM files could be generated from this as well, like the constraints, the packages you built from the repository. So here, if you build two OPAM packages, the constraints across those can
you could do that. Yeah. Well, technically, what you could do is ask Jbuilder to check it for you. Like, it will tell you a warning if you didn't put it right.
Right. Like the two package names.
Yeah. On this subject, so initially, like I said, like Jbuilder can find the dependencies without running anything. So, for example, I remove my build. I ask it what are the external dependencies? Target. So to build the install target, and it will tell me I need CMD liner, and it has built nothing.
And that's at the OCaml find level, right? So Jbuilder doesn't know that OPAM.
Sorry.
Is that the OPAM package missing? Or
No, it's the OCaml find because I don't know what OPAM package is part of, basically. So it's an approximation. Like what you would need is a mapping between the package and files, but well, that's starting to be complicated. You could have another tool, on top of Jbuilder that would do that. But you could ask Jbuilder, tell me all the external files I need, and then it will tell you.
Or increasingly, we're moving towards one-to-one correspondence between.
Yeah, that sounds.
Yeah, that's even better. Basically.
Get rid of names.
Yeah.
Multiple name systems.
Yeah.
So really, for this to be simplified, we now need the year-long process of moving hundreds and hundreds of packages over to these kind of standards.
Yeah.
So Jbuilder just enforcing a certain hygiene, what it does by default, like will make this just work. Same way two package did for a number of things.
Yeah.
So.
All right. So now I'm going to show one last thing. I wrote my package. I want to test it. So as I said before, like on several versions of OCaml. So I'm just going to show you how to set this up. So to use this feature of Jbuilder, you need to set up a workspace, which is essentially like you tell Jbuilder, okay, consider all these tree, like as a wall, all the packages in it, consider them like in one invocation. And to do that, I need to create a file called Jbuild workspace with a configuration of the workspace. So in addition to setting up the workspace, this file will set up the root, basically, so I could put it in the top directory. So if you wanted to organize, for example, your workspace with all the projects side by side, you would just put them in the directory and put the Jbuild workspace here. You could also, if you wanted, create a depth directory and put them here, like it's up to you. But typically using workspace, will set the root. So in this workspace file, I will just list essentially my build context. So, and typically, like a build context, it will be an open switch using your root as configured. So you just need to tell the switch. So let's see what switch I have installed on this. We have 403 and 401. So I'm going to say 403. Like this. And that will tell Jbuilder to build everything for like these two environments. So now if I do Jbuilder build, well, I guess, yeah, CNG liner is not installed in one of the switches, so it doesn't work. But essentially, it will create, see, like two build contexts with two sets of artifacts.
Do the logs tell you which build context failed?
Does it? I don't know if I added it. Oh yeah, so the log here, it's, well, you can't see it because it's, yeah, it's better on a black background. So it's actually, Stefan, we implemented this. We implemented like the rendering. I'm not saying it's bad, but like it's nice that show you, you know.
It's ghosts, isn't it? Yes, you can just see them.
But yeah, so like with the right color, but anyway, who use white background? I mean, like real programmers use black background. There's no question for passing.
Oh, you highlight the text.
Yeah.
What color is your terminal?
Yeah,
oh, it does tell you. It does tell you the context.
Yes, that's quite nice. This thing.
And this is barely adequate punishment using a white background.
This is for things. Yeah. Oh, yeah.
Excellent.
And well, that's all for this demo. If there is any question you want to ask about Jbuilder, like something you want me to show now, feel free to ask. Otherwise, you can just wait for the food. Yeah.
Oh.
Can you also customize the dev flags?
So yeah, currently, Jbuilder has like a dev mode. So if you do Jbuilder build /dev, it will build things like in a development setting, so that needs more warning and things like this. And typically, so when you release, you shouldn't use the dev mode because you don't want things to break if there are more warnings. But when you develop, you want all the warnings to get good quality code. So you pass Jbuilder.dev. Currently, like the flags, it will pass to the compiler, it starts calling into Jbuilder. Later, you will be able to customize them. So for now, like I've been mostly focusing on the release path, like getting things right. Like all these nice things that will come, with time, basically. But yeah. This will be added.
The other really useful one, I think, for a lot of our repositories, maybe not the Jane Street ones, is you can clone multiple things into subdirectories and just do Jbuilder at the top level.
Yeah.
So that's working extremely well.
Yeah.
So I think I've been trying about 25 repositories, and the null time is instantaneous. And, it's very nice. So adding OPAM plugins to do the sourcing cloning automatically. So hopefully that it might mean that when you do OPAM install in the future, if it's all Jbuilder, it doesn't need to run any build commands at all. It'll just at the end of the source thing, it'll just run Jbuilder once.
That would be awesome. You're planning to abuse the thing that you
Yeah, but the thing is, what that gives you typically is that you get better parallelism. Because currently in OPAM's parallelism is at the level of one package. So if you have the whole DAG, you can parallelize better. Another thing is that currently in OPAM, let's say you have four cores, it will build, if you build two packages in parallel, it will build one is 2 cores, the other one is 2 cores. If the first one finishes very quickly, the other one is stuck with 2 cores. Well, if you build everything at once, well, it's good.
It's a slightly horrible, but can you make job server?
Yeah, job server. So I've looked at this, basically, we will need support in OPAM, basically, because OPAM would need to set up your thing. It's like annoyingly painful to implement on both Unix and Windows, because essentially multiplexing process on I/O is super painful. So it would be maybe like easier to do it with Phrase, I don't know. But yeah, that would be a possibility. That would be a possibility.
It's done using crazy tokens servers.
Yeah,
Windows one always mean you get error messages at the end that it's dropped tokens somewhere. And it's nowhere they've gone.
Yeah.
It's even worse if the make JavaScript protocol because the tokens are bytes in a pipe.
Yeah,
Yeah.
it always gets to the end saying,
When you want to say, hey, it
Yeah.
makes a pipe, let's say it pipes into it, and then every submake tries to read pipe from the pipe. That's its relation to what
Yeah.
Yeah.
Amazing. So I guess somehow I guess there's a really good opportunity to get every Windows ported as well. So how many people here need Windows compilations? Generally part of so everyone's doing it at different times. So okay, yeah, but about half the room and pretty much So in terms of contributing to Jbuilder, for example, your command liner one was interesting because there's a really common recipe there that most people would need, right? If you're just building a single binary executable, you don't want to install the man pages and do sensible things by default. And the minus help is pretty standard. So is that something that should be lifted into a tool and sent as a PR to Jbuilder?
Sorry, what?
Is that something that would be useful for other people to contribute to just common high-level rules for things?
Oh yeah.
If we're cutting it like C-type rules are a good example.
Yeah, possibly. I mean, yeah.
But those have to be translated into the Jbuilder rules, right? You can't just submit like right now we're just cutting and pasting X expressions, but I guess we need to translate those into the actual OCaml rules.
Oh yeah. Yeah. But it depends, I guess. For C types, you could just generate S expression because they are relatively simple, the rules. Like for things like JS OCaml, it's impossible because you need to set up like the build of all libraries. And in fact, JS OCaml, it even like gets your installed libraries and converts them to bytecode on the fly. So, like to JavaScript. But yeah, well, I guess if there was a need for it, like we could have like a very simple plugin mechanism where you would generate this expression. I don't know, like.
But just for now, it's easier just to contribute rules. And get rid of the shells and stuff. Because the biggest part of Windows support is if rules proliferate that are not Windows compatible, it'll take us another 10 years to fix it. So I'm just wondering if we can have a gold standard of rules that just work for things.
Just have Jbuilder wall if you've got anything that says shit. Seriously.
I think some of these.
Well, basically, you have like so in the DSL you have like a system form basically that uses well either a shell or CMD.txt, and basically just like and you have even like a bash one because just like sometimes you have a test you don't care about its portability, you just.
I guess the other half is convince Windows developers to start using Jbuilder as well and see what we can do with that.
Yeah, but yeah, I tried it on Windows. It works quite nicely. I saw people like the other day trying to use it on Segwin, and it's like, why do you use Segwin?
Yeah, that's a good question. I think all of you is here. So should we thank Jeremie for a great job? And also just thank you to Jenga for organizing all the food and our Labs for sponsoring it. So thank you, Jenga.